So good evening all. I hope
Good
it
evening,
is,
sir.
it is visible, and we will continue our discussion on descriptive statistics. And today we will be actually focusing on some previous year questions. Okay. So can you see uh, the first question itself? What is the first question? Is it visible?
Yes, sir.
Let me expand it and let me minimize this also. So what was the question? Given, what is given to us? Mean is given 45, mode is given 48, and you have to find out median. Okay. So how quick you can do it? You just see the formula over here, isn't it? What is the formula? Mean minus mode will be equal to 3 times mean minus median, right? Sangeeta? Hello?
Yes, sir.
So are you doing it?
Yes, sir.
So what will be our answer? Yeah, you need to solve in maximum, easy questions within 2 to 3 minutes.
Yes, sir.
Then only you will have time for difficult questions. So the answer will be 46. Why it will be 46? Although we have already to save our time already we did it. So basically yesterday we discussed also, right? So skewness is this relationship, okay, for a moderately skewed distribution. Mean minus mode will be equal to 3 times mean minus median. Okay, so directly you replace the value, then you will get it. So this is simple, right? I hope everyone is clear. Sangeeta?
Yes, sir. Yes, sir.
Okay. So difficult one we will discuss, because the a little easier one we can skip. So you can see over here. First, another question is there. Geometric mean is theoretically considered as the best average to construct index number, and reason is geometric mean is used if the range of observation is extremely large. Okay, so the answer will be A is true, but R is false. Can anyone tell that without looking at the answer? Why the reason is false over here? A is true, we know, because yesterday also we have, when we are discussing, I think, geometric mean, we know that geometric mean is the best average to construct the index number. Already we know it, right? But why R is false? Sangeeta?
Sir, because it is difficult to calculate if the values are extremely large.
Okay. What is say? First is what it is saying. The geometric mean is indeed considered the best average for constructing index number, because it balanced upward and downward movement effectively, and it is multiplicatively consistent. Already, if I remember, uh, uh, what is the formula of geometric mean? So let us write that quickly. G will be equal to
X1,
uh,
X2.
x1 into x2. It will be multiplied, right? Into xn
XN.
up to root n. Okay. So this is your geometric mean, right? So what it is saying? Geometric mean is the best average for constructing index number, because it will balance upward and downward movement. effectively and it is multiplicatively consistent because you are multiplying na here. Are you getting my point? That is why it is saying. And reason is why reason is false, because the geometric mean is not chosen specifically because the range of observation is extremely large. Rather, it is preferred for ratio, rate of change, and index number due to its ability to handle proportional growth well. Okay, so that is the reason. But this is not extremely large. This reason is not the correct reason. Is it clear? Sangeeta, shall we proceed?
Yes, sir.
Okay. So next, I think this is a very interesting question. Who is going to tell me? Because geometric mean of last pairs and psyches indices provides what? Who will tell? Madhusmita?
Sir, Fisher index.
Fisher index.
Fisher index, sir.
You all know it, right? Very good. But now we'll discuss each one of this index. Okay?
Yes, sir.
So what is this index? Who will tell that what is Marshall and Edgeworth index? Means what is the formula? All if you are know about the formula, right? And the test. So that of course we will discuss not today, but I'm just trying to tell you. You have to remember like Edgeworth. First one is Edgeworth Marshall's index, right? So what is the formula? If you know it, so it is basically summation Qn into P naught plus Pn upon summation Q naught into P naught plus Pn into 100. But what you have to remember here that in Edgeworth-Marshall's index, sum of base and current period quantities, okay, that is very important over here. So, next one is Bowles index, okay. Anyone can tell me what is the formula of calculating Bowles index? Ajay?
No, sir, no idea.
No idea. Okay. So basically, you should remember that arithmetic mean of last pairs index. Here it is not given actually. Means although it is there in this question. So the arithmetic mean of last pairs and psyches index is known as Bowles index. Okay. M of, please write it down. Arithmetic mean of last pairs index and psyches index is known as Bowles index. Okay. So how you will write? Have you noted down this formula? So Marshall Edgeworth index. So half. Shall I remove it? This formula. Sangeeta.
Yes, sir.
Okay. Is it clear? What is Bowles index? It is arithmetic mean of Laspers
Laspers
index and Psychase index. Okay. So why I am telling you, if the question will be
Sir,
little
it is
different.
sir, it is written last year's index and past year's index here.
Huh. Past means psyche, means that is actually we call it Psychase index. Okay.
So last year's acha arithmetic mean is Pauli's index and geometric mean is Fisher's index.
Arithmetic mean is Bowley's index. Yes.
Okay, sir.
That answer I will come. Okay. But I am just telling you the formulas first. So
Okay, sir.
Bowley's index is basically arithmetic mean, and the geometric mean of the question is the geometric mean of Laspers index, and Psychase index is Fisher's ideal. Fisher's basically ideal index. This is already, I think you, all of you have given the answer, right?
Okay,
Isn't
sir.
it? Yes or no?
Yes, sir.
So, what is the formula for? Because this is very important. With one question you will get. So, Bowley's index is basically Laspers index. Laspers index plus Psychase index. Okay. And if you will write it, so it will be like this, half. Is it visible, everyone?
Yes, sir.
P1 P and Q naught upon summation P naught Q naught plus summation Pn Qn upon summation P naught Qn into 100. Is it clear? So obviously here this part is Laspers. This is Laspers. Li will write short form, and this is Pi. Is it clear? Sangeeta, is it clear?
Yes, sir. Yes, sir.
So if the question will be the arithmetic mean of Laspers and Psychase index is what? So answer will be
Bowley's index.
Bowley's index.
Bowley's index.
Yes, that is important to know it. Okay. Okay, so I gave you idea about Bowley's index. Then what is next? Fisher's ideal index. Already we know it, right? Fisher's. Maxwell-Leshurst already I told you. Bowley's index already I told you. Fisher already you know it, right? So how will write Fisher's ideal index geometric mean? Means what is the way to write it? Means I'm just telling you how you will write in mathematical notation.
The
Means,
root over of PL into PP.
okay, very good. Madhusmita.
Instead of half, we have to put a root over.
Okay, great. Just give me a second. Just give me a second. Maybe we have to use a whiteboard when we'll be discussing this. Okay. But I think here it is also very clear, right? Isn't it? Yes or no? So,
Yes, sir.
what you all have told, Fisher's ideal index. It is also called ideal index. Okay. Or this is, you write like this. The subscript you have to be very particular. So it is I 0 n. We write like this. Okay. So you will be writing square root of Li, short form, Laspers index into Pi, Psychase index. Okay. So already you know the formula. So we are not going to write it. Or if we will write it again, so it will be practice for you. Pn Q0 upon summation P naught Q naught. Yes. Sangeeta, can you tell me
Yes,
the
sir.
other one?
Sir,
Psychase
plus
index.
or into?
Plus, this is not plus. This is into. Into.
Okay.
Because geometric mean, na? This is geometric mean, right?
Yes, sir.
Uh, I'm asking actually the other part, Psychase index formula. Summation.
Sigma summation
Yes.
PnQn
Yes.
divided by summation P naught Qn.
Very good.
Sir,
Into
into 100?
1 to 100 and then square root of only this part only. Okay. Then into
Okay.
100.
Okay, sir.
Okay.
Okay, sir.
So, this is already, I think, the one more index which is written over there. Ajay sir, you know it? Kelly's index. Don't see any Google or don't use any internet when you are answering the questions, okay? Otherwise, you will not be able to answer properly. Chinmay madam, will be able to tell what is Kelly's index. So basically, I am just telling. I hope Chinmay is there, right? So
Yes, sir.
if the weights basically kept fixed for all periods, means weights are constant quantities without any reference to the base or current period, then we get actually Kelly's index. So that is basically we write like this. I0n is equal to summation Pn Q upon summation P naught Q into 100. Okay, this is also known as aggregative index with fixed weights. Okay, aggregative index with fixed weights. Clear?
Yes, sir.
Okay, very good. So now already the formula, the answer is given over here already, which we have discussed, isn't it? This is the short form we had written. So, but we have already discussed in detail, right? This is something interesting regarding yesterday's discussion on measures of dispersion. So, whether anyone can tell me, yesterday we have discussed what should be the ideal skewness value for a normal probability distribution curve or normal curve? What should be the value of skewness? Sangeeta?
Sir, 99.90.
No. Chinmay, what I asked that if a curve is symmetric or normal probability curve for a bell-shaped curve, okay,
Mm-hmm.
what should be the value of skewness?
Sir, 0.
Zero.
Sir.
Zero. I maybe
Zero.
you have mistaken,
Yes, sir.
but you know the answer.
Yes, sir. I didn't understand the question, sir, first.
Yes. So skewness is zero. Okay. So now the question number 14. In a frequency distribution, the standard deviation of which is 15.8, and the value of median is more than mean by 4. What will be the coefficient of skewness? I think this formula, the other one which we discussed, you have to remember actually. Otherwise, there is no previous this one. This mean minus mode equal to 3 times mean minus median. This is also very important, and this one is also very important. 3 mean minus median divided by standard deviation. So what we are having answer, the already we are having median, right? Value of median is more than mean by 4. So mean plus 4. And so mean minus median will be How much? Minus 4. Yes or no?
Yes, sir.
This is true. So skewness is 3, mean minus median is minus 4 upon 15.8. So it is minus 12 upon 15.8, that is minus 0.76. So minus 0.76 means, let us little discuss, it will be negatively skewed or positively skewed?
Negatively
Negatively skewed.
skewed.
Negatively skewed, what happens to the mean, median, mode? Yes, who will tell? In case of
Sir, mean
negatively,
is greater
When I
than median,
distribution,
greater than mode.
mean is greater than median.
Mean is greater than median, then mode.
Mean is greater than median. Is it correct?
yes, sir.
Yes, sir.
Okay. Mean is greater than median. Median is greater than mode.
Mode.
Okay. And in case of positive skewness,
Mode is greater than median. Median is greater than mean.
okay, very good, excellent. It means you have remembered what we have discussed. Can you just tell me another application questions? Okay. Suppose let's say that we are dealing with a data, so it is a little application oriented question which is not here. Okay, I'm asking you. Suppose we have captured the students' income, means basically their family income, and if the income which we have captured and we got actually negative skewness, after calculating the incomes, whatever the data we are having, then what does exactly it means in reality or in sentence, in text form? You understood my question, right?
Again, sir.
Huh?
No,
Again,
sir. Yes,
again,
sir.
what I am trying to tell you is, let us say that we have collected data on family income of a class which we are teaching. Okay, so we got family income and we calculated the skewness. Okay, and we got negative skewness of that data. So what does that mean exactly for, like, not only for further statistics which we will be calculating, but I am more interested in terms of interpretation, in terms of negative skewness interpretation. Is the question clear?
Sir, yes, sir. Sir, in my perspective, it states that there is a more inequalities in income.
More?
Inequalities.
Sangeeta, any idea?
Yes, sir. From my view, sir, I think very less number of family income is large and large number of family income is low, which means there is income inequality.
Okay. So, like what I told you, like how the data, the negative skewness data will look like. It will look like
Sir,
this. Let me draw it and you can correct me. Like it will be like this, right? Not exactly like this. Yeah,
the
kind
tail
of.
will be towards the left, sir.
Tail is towards left. If you will see this side, okay.
Yes,
So
sir.
like it will be little picked here. So like this, okay.
Yes, sir.
So towards left means what? What exactly you are saying?
It means, sir, less number of people are having more income, and very few family are having large income, which means, as we know that, sir, in negative skewness mode, mean is greater than median is greater than mode. So mode represents the highest frequency. So sir, highest frequency means more number of people are having less income.
Okay, I think it's fine. And if it would have been positive skewness,
Then sir, income equality, then opposite, because more people will be having the same range of income, which will represent more frequency, same frequency, sir.
Madhusindra?
Sir, if the curve is positively skewed, then it indicates there is a less inequalities are there.
Why? Because mode is greater than median,
It is
greater
more.
than
Better than
mean.
me.
Mm.
But as I told you earlier, for interval and ratio variables, the mean is not appropriate, right? Or mean is
Okay.
Yes,
appropriate.
sir.
Mean is the most appropriate, right?
Yes, sir.
And
Yes,
Yes.
sir.
income is a which type of variable? Means which how it is measured in on which scale? Interval or ratio? Ratio scale, right? Ratio scale. It can contain true zero. Okay. So
Yes,
Yes,
sir.
sir.
when mode is there, you can say on
Both
positive.
scale we can measure now, sir. Ratio scale and interval scale.
Yeah, both, but ideally it should because ratio scale is a special case of interval, na?
Yes,
So,
sir.
so it is ratio scale. Okay, so I am just asking you this question, so that you can apply it. Okay, so we will discuss more maybe when we will do some application oriented question. So now this formula, just another question which is not written over here. What it is called? This formula. Anyone can tell me? This formula is called what? Carl Pearson's second measure. What it is called? Second measure. Then what is the first measure? You should ask me.
Yes, sir.
Pearson's first measure is mean minus mode. Skewness is equal to mean minus mode upon standard deviation. Standard deviation. This is
Carl Pearson first
first
coefficient
measure.
of skewness.
Yeah, Pearson's first measure. Okay,
First measure.
first measure. Okay, you are going definitely you are going to one question on skewness. I am 100% sure, but we will discuss further whenever other questions will come. So this is
Sir,
fine. We have
sir, did we answer it correctly?
which one regarding the application question?
Yes, sir.
Uh, because yesterday I am just telling you yesterday what I told you. I can show you what exactly we have discussed yesterday. Okay, then you will relate it. Okay,
Okay, sir.
you have asked a good question. So positive skewness means when a distribution consists of too many large values and its tail
Hmm.
is traced to right.
Right.
Okay.
Yes,
And
sir.
negative skewness means when a distribution consists of too many small values. So I think your answer is correct given the what we did yesterday, right? Because you are
Yes, sir.
saying if it is too many small values, it means what you could have better not you have given a generic income inequalities rather than you could have told that if we got negative skewness in our calculation of family income, it means there are many families who are earning very less.
Yes, sir.
Because if you want to say regarding income inequality, again we have to calculate Lorentz curve. Okay.
Hmm.
But prima
Yes.
facie, just by looking at negative skewness data, you cannot say much about income inequalities. Okay.
Yes,
Technically,
sir.
scientifically. Okay. But yes, it is a point like towards your what you are trying to say. It
Yes,
might
sir.
be just an input. So similarly, if you would have got a positive skewness value, then you could have told that there are a lot of actually rich families are there. Okay, because we
Okay,
got
sir.
lot of actually many large values, so that is the reason why the tail is actually towards the right. Positive skewness means.
Okay, sir.
Correct? Correct?
Okay, sir.
Making sense?
Yes, sir.
Okay, great. So that is how you attempt actually when we are trying to discuss the question. So we have to discuss everything related to that particular question, so that uh, we will be prepared for any questions. Okay.
Okay, sir.
So I hope it is clear. Now next question. I think in a frequency distribution, if each item, see yesterday we have discussed, each item is multiplied by 5, the coefficient of variation will remain. So who will tell me? Let me ask not Sangeeta. I'll ask Chinmay.
Yes, sir.
Coefficient of variation is which type of measures of dispersion? Is it
Quotient is a relative measures of dispersion.
relative measures of dispersion? Very
Dispersion.
good. Now, if you have remember, we have discussed independent of change of origin and change of scale, isn't it? But not
Yes,
for
sir.
coefficient of variation, we discussed for standard deviation. Okay.
Yes, sir.
So, here what is the question? Just check the question. If a frequency distribution, in a frequency distribution, if each item is multiplied by 5, the coefficient of variation will remain unchanged. It means what? Is it independent of change of origin or uh, change of scale?
Independent of mm, scale, sir.
Scale. Okay, very good. Because it is multiplied, right?
Yes, sir. Yes.
So it means coefficient of variation. So what is the formula of coefficient of variation? Standard deviation
Sigma
upon
divided by
sigma upon mean. Standard
mean
deviation
into
upon mean.
mean
Arithmetic mean into 100.
100.
So if you will multiply all the observation by 5, or if you will divide also, if the question will be divide, so then also it will be remain unchanged. But what about change of origin? Ajay sir,
Or- Origin is
Addition or subtracting some value.
that I
The
know, that I know. But I am asking if the question would have been different. In a frequency distribution, if each item is added or subtracted by 5, the coefficient of variation will remain unchanged or changed.
will be change, sir.
Madhusudha,
The coefficient of
Sir,
variations will
the
change.
coefficient.
change, right? Change by how?
Yes, sir.
By what amount? Means what will be the value? Like if it will change, then what will be the value? Are you getting my question or you are not able to understand my question? First of all, let me tell you some important information which is not mentioned over here. So let us clarify. First, as already Chinmay told, it is a relative measures of dispersion and it is independent of the unit of measurement. It means it will be not affected by the unit of measurement. Is it clear? Sangeeta?
Both sir, change in origin and change in scale, or because I have
No, no,
written here that
no,
standard deviation
no,
is
no.
independent of change of origin.
Yes, you are correct.
But
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 I am not answering your question right now. I will come to that. What I am telling
okay,
you, right now I am focusing on the definition of coefficient of variation.
okay,
So
sir.
I will come to your point. What you have written, you are saying correctly. I will come to that. But what I am telling you, coefficient of variation is basically standard deviation upon mean into 100, right? It is a relative
Yes,
measures
sir.
of dispersion, and it is
Yes, sir.
independent of the unit of measurement, not independent of change of origin and change of scale. I will come to that later on.
Okay, sir.
So it means when coefficient of variation you are calculating, then you are actually, it is a unitless, whatever the value we will get of coefficient of variation. So there is no unit, okay? It is a pure number. Are you getting?
Okay, sir.
Because it's a relative measure, na? It is standardized. Isn't? Are you getting my point? So there will be no measurement unit, right? Of any of the measure which you are calculating. Is it clear? Because when we are saying relative measures of dispersion we are using, because there are two series where we have calculated coefficient of variation and we want to check which series is more variable compared to the other one. Are you getting my point? I told
Okay, sir.
that is the reason. So whenever there is a relative, the key word is what? Whenever there is a relative measures of dispersion, then we are actually, because we are comparing two distribution or two series in different units, so that is why relative measures of variability, whether it is coefficient of variation or whether it is coefficient of quartile deviation or coefficient of mean deviation, all these are actually independent of the unit of measurement. It means unit of measurement of any of the series is not getting reflected over here. That is for sure. Okay. Now, as I was trying to tell you, I think Sangeeta was trying to tell me, yesterday we discussed standard deviation is independent of the change of origin, but what is the, can you complete the sentence?
But standard deviation is dependent of change in scale.
Change in scale.
Scale.
So here, now it is the time to discuss this. So coefficient of variation is sigma upon x bar into 100, and if each of the item or each of the number is multiplied by 5, so the new mean is 5 x bar, and new standard deviation is 5 sigma. Okay. Now straight away from here you can see this is getting cancelled out, isn't it?
Yes, sir. Yes, sir.
So that is the reason why it is
Same.
same. And
Independent.
sorry.
CB is independent of change in
Yes,
scale.
change in scale. Okay. Now if it will be added 5 plus sigma, then it will be 5 plus x bar. So let us take one value, then it will be clear. Suppose let's say the standard deviation is 2, mean is 5. Okay, into 100. So what we will do is we will add 5 over here, 5 plus 2 upon 5 plus 5. Can you just quickly tell me?
7 by 10.
So it will be 7 by 10. Definitely the answer will be changed. I think Ajay told the correct answer, right? So it is not independent of change of origin.
Origin.
Ajay, you meant to say this?
Yes, sir.
Okay, great. You are having clarity. Very good. So, but what I told you, you should always remember that whenever we are using, relative measures of dispersion, it means there is no unit of measurement. This is also another important dimension. Okay, independent of origin is, and change of origin and change of scale is one important factor, or it is very important characteristics. Second important factor is whether it is independent of unit of measurement or not. Okay, that I think yesterday I forgot to discuss. That is why I brought this. Next question. Geometric mean of 2 6x is equal to 6. Then what will be the value of x? So here the formula of geometric mean will come into the picture. Okay. I think this is self-understood, isn't it? Because we can write small g is equal to, Chinmay, is it clear?
Yes, sir.
x1 times x2 into xn. So here already 2 6 x is already given over here. 2 into 6 into x is equal to 6. So to the power, or you can take root, okay, root q. So already we have written. So now you can rearrange. So it will be 6q is equal to 12x, and 6q is 2 and 6 equal to 12x. So here what is important over here, I am telling you, before you attempt this kind of question, please be comfortable with exponents operations. Exponent operations. Okay. Tomorrow I will share a folder. I will share some important textbook where we will review some important basic mathematics skills. Okay, Sangeeta? So
Yes,
that
sir.
it will help you in manipulating the numbers. Okay, is it clear?
Yes, sir.
So 6q is equal to 12x. So now I think all of you can easily solve it. Okay, that's not a problem. Clear? Now next question. Standard error of large sample of size n from a population whose variance is sigma square is what? Is sigma upon root n. Yesterday what we had discussed, standard error is what basically? Who will tell me? Ajay, what is standard error? Quick, otherwise next question will be passed to the next person. Madhusudha,
Sir, through the standard error, we are measure how the distribution, how the elements are the particular distributions far from their mean value.
no. What you are saying? Can you tell me again?
Sir, through the standard error, we are able to measure how the in the particular distributions elements are far from their mean value.
No. Sorry, I'll come to that. Chinmay, you want to pass the question or you want to answer the question?
The square root of variance.
Okay. Square root of variance. But
Variance.
you are not answering. You are just telling the formula, not the answer. That already I know. Some Sangeeta, you want to pass the question?
Sir, Madhu madam has said it correctly, but I want to add it that it is the standard deviation of the sample from its mean.
No, I think none of your answer is correct. But not a problem.
Ma'am, sir,
You are close. You are close. So let me
sir, I want
close.
to say one time again.
No. Let me close. Okay. Then you will say. Okay. Why? Because yes, you all are close. Okay. First of all, let me break down this. Now, Madhusudha, you can tell what is standard error.
The standard error means how the sample mean is far different from their population mean.
First, you should know standard error of a statistic. A statistics means whatever the formula or we use, calculate from the sample values. Statistic, right? Statistics and parameter already
Yes,
you
sir.
know, right?
Yes, sir.
Statistic is you calculate from the you can say statistical measure which you calculate on the basis of sample observation is called a statistic. Is it clear? Like for
Yes,
example,
sir.
sample mean, sample standard
Sample
deviation,
stand. Yes,
right?
sir. Yes.
And any
Yes.
statistical measure based on all units in a population is called parameter.
Parameters.
Like population mean, population standard deviation and all, right?
Yes,
So
sir.
now the question is which I had asked, standard error of a statistic is the standard deviation, is the standard deviation is the standard deviation is the SD calculated from the sampling distribution. This is the keyword, calculated from the sampling distribution of the statistic, from the sampling distribution of the statistic, okay. So this sigma upon root n, we should actually write here, it is partial, it is written, you should write standard error of sample mean, in bracket you will write x bar, which is equal to sigma upon root n. Is it clear?
Yes, sir.
Or you want to say you want to tell the same thing, Madhusudha?
No, sir.
Is it clear now?
Yes, sir. Yes.
So basically, if the x bar, which I have written over here, if this x bar represent the mean calculated from a random sample of size n, and the standard deviation of the population is sigma, then the standard error of the sample mean is given by this formula. Okay, is it clear?
Yes, sir.
I think the choice are mentioned over here, but yes, we can discuss, not a problem. So this represents already the standard deviation of the sampling distribution of the, I think Samhita is that. So I hope it is clear, right? So this is clear, standard error. Yesterday we had discussed standard error and sample size. So what is the difference between like if the sample size will increase, what will happen to the standard error of the mean? Chinmay? If you will, it is like this, if you will increase your sample size, what will happen to the standard error of the sample mean? Quick, we are not having time.
Increases.
Decreases. Standard error will decrease.
Standard error decreases.
But you are saying,
Reduces, sir.
no, one by one. So Chinmay, you told increases or decreases?
Sir, increases.
Increases. How it will increase? It will decrease. Sigma upon root n, na?
Okay, sir.
So this value being, this is a constant, so this value will increase means what? This whole ratio will become what? Because it is root n, you have to remember that. Are you getting? Suppose for example, you take standard deviation as 2. So
Okay.
let's say that 4 was earlier your sample size. So 2 by 2 is your 1. This is your standard error, right? Now what we will do is, we will take 16. Standard deviation is, let's say that it is 7. Let's assume.
By 4.
So what it will be? 4.
2 by 4.
2 by 4 is how much?
1 by 2.
1
by
by 2
2.
is 0.5, na?
Yes, sir.
So this is decrease or not?
Yes. Yesterday we had discussed this, sir.
So standard error, but we have not discussed the numerical.
No, numerical not, sir.
Standard error will decrease if actually we are going to increase the sample size, because that is why it might come also in your first paper also. So that is why you should remember this. Standard error is a very important parameter, or you can say important statistics, not parameter. So, and this depends upon three important, I think four variables. Standard error, then ultimately what are the factors it depends on? First is sample size. Second factor is nature of the statistic, means what you are calculating, that is also important. Then third is mathematical form of the sampling distribution. I am not writing completely. Fourth is the value of the parameters used in the sampling distribution. Okay. So it is clear. That is the reason why we want to increase our sample size all the time, so that our standard error will be minimized. So now, can anyone tell me what is the difference between standard error and standard deviation? What is the formula of standard deviation? Sangeeta, question is to you.
Standard deviation formula, sir.
Yes, standard error and standard deviation, they are different, na? Just now we
Yes, sir.
discussed. Then can you just tell me what is the sigma? Sigma is standard deviation because it is a statistic which you are calculating for the sample, right? Then what is the value? Summation x minus
X bar
square
square
upon n.
1 by n root over.
Yes, correct. So basically, standard deviation gives you, or let's say that if you are having in this case x1 to xn, so what exactly standard deviation is telling you? It is giving you the idea of the variability or dispersion.
Yes,
Okay.
sir.
So, but standard error is another statistic which is a measure based on the sample observation. Okay. So that is why standard error, already I told you, sigma upon root n. But here standard deviation, it tells us, it gives us the idea about the variability of all the series values from its average value. So we'll stop over here, then we'll continue the other year discussion. So thank you all for motivating me. I'll stop sharing.
Thank you,
Then
sir. Thank you, sir.
Thank you, sir. Good night, sir.
yeah, so let me stop the recording.